Trig pre-college factoring video. Expressed in simplest form. So, over the past few years, you've learned factoring pretty much every year. Um, a lot of different styles of factoring came into Algebra 2, and you learned them all in the beginning of the year. So it's been probably about a year since we did some of these factoring styles. So hopefully this video can refresh your memory on how to properly do a bunch of these. Now, we're kind of jumping right into it with this problem. And so what we see here is a fraction divided by a fraction, and what we need to do is multiply by the reciprocal. So no factoring just yet. I just want to set this problem up to be the top fraction, 4 minus x squared over 7x plus 12. And instead of dividing fractions, I'm going to multiply them, but I'm going to flip this fraction as a reciprocal. Remember, multiply by the reciprocal of the bottom fraction, so x plus 3 over 2x minus 4. All right, now at this stage, I need to factor everything that I can. This 2x minus 4 is a GCF. I could take out a 2, and I get x minus 2. And right there, that's the first thing you want to look for when you factor, is you want to look for GCFs. If it's not a GCF, then you want to think about trinomials, difference of two squares, grouping, and things of that nature. But I clearly see a GCF there. This other denominator, x squared plus 7x plus 12, is a standard trinomial, factors to x plus 3 and x plus 4. And that should be pretty automatic for you by now, what multiplies to 12 and adds to 7, so on and so on. 4 minus x squared is not a GCF. It's not a trinomial. It is a difference of two squares. 4 is a squared, and x squared is also a square, and we're subtracting. That's the difference part of difference of two squares. And so it factors to 2 minus x and 2 plus x. Now, you may have thought, well, isn't it x plus 2, x minus 2? Well, if it were x squared minus 4, like if this was reversed, then it'd be x plus 2, x minus 2. But because it's 4 in the front, I got to have the 2's in the front. I got to keep the same order. And so these are the things that can be factored. This x plus 3 here, this can't be factored. I'm rewriting it just because I have all my factor terms in red, so to keep them the same. But that can't be factored. There's no GCF. It's not a trinomial. It's not a dot set, so on and so on. So now I just look to cross things out. I could get rid of an x plus 3. And now you're starting to wonder, well, what about this x minus 2 and this 2 minus x? Can I cross those out? And the answer is yes and no. No, you cannot cross them out as they are right now. But yes, we can cross them out if we do something. The reason why you can't cross them out is because minus is very particular. Like 1 minus 7 and 7 minus 1 are not the same thing. So we couldn't do that. Now, if it was plus, say it was x plus 2 and 2 plus x, then yeah, I could cross those out. Because addition, the order doesn't matter, but subtraction it does. So I can't cross them out just yet. But I can cross them out when you want to do that. I just have to leave a negative 1 in place of the substitution, of the crossing out. Now, it doesn't matter if I leave the negative 1 here or if I leave the negative 1 here. I do not leave it in both spots. I have to pick one of the two spots and leave a negative 1. And I'm going to choose to leave it down here because I'm going to multiply it by this negative 2 here. But what that means is because you have a choice on where you leave that, some of your answers might look slightly different, but they would still be correct and equivalent. And so that's it for crossing out. We cannot simplify anything further. So what we have on top is a 2 plus x. And what we have on the bottom is a x plus 4. So let me just circle what's left over. An x plus 4, a 2, and a negative 1. And I can multiply these 2 and negative 1s to be negative 2, and then the x plus 4. And remember, that's it. That's as far as I go. I cannot simplify these because this 2 is attached to this plus x. That's an entire expression. I would only be able to eliminate with a similar 2 plus x or x plus 2. And so this is it. That's my final answer. And so you're going to be left with sometimes multiple pieces. All right, so that's it for this one, but let's try some more factoring problems. Now again, just before, say I did leave the negative 1 up here instead, then I would have a negative here, and this would be positive, and so on. So, and then, you have the option of, should I distribute this? You can, but you don't have to. So there's a lot of different ways to express the answers to these problems sometimes. The next one, factor the expression 12 t to the 8th minus 75 t to the 4th. So clearly it's not a trinomial. There's only two pieces. It's not a dot because 12 and 75 are not square numbers, but there's definitely a GCF. I recognize that they both have t's, but 12 and 75 could also both be divided by something. Let's see, they could both be divided by 3, right? And since they both have t's, I have t to the 8th and t to the 4th. That means I could take out as much as t to the 4th. And what's going to be left over when I factor 3 from 12 is 4. And when I take t to the 4th from t to the 8th, I'm left with t to the 4th minus factor 3 from 75 is 25, and the t to the 4th is completely taken out. Now, this is a factor completely problem, meaning I want to factor all the way. And you should do this anytime you factor, really, that after I factor, I need to re-examine what's left over and determine, can it be factored further? And so 3t to the 4th, that's factored all the way. That's not going to change. But what's in here? Now, 4t to the 4th minus 25. Is there a GCF? Is there a greatest common factor? That's always the first thing you want to look for. Is there anything in common? The answer is no. This doesn't have a t, and 4 and 25 can't be divided by any common factor besides 1, which won't do anything. So it's not a GCF. It's not a trinomial. There's only two pieces. Is it a difference of two squares? Well, my numbers are 4 and 25. Yes, they are both square. And t to the 4th, it's not t squared, but it's even. And what that means for exponents is if you have an even exponent, it's considered square. So yes, this is a difference of two squares, so it can be factored further. And it would factor to 2p squared plus 5 and 2t squared minus 5. And this, now I want to look at these one more time. 3t to the 4th, that can't be reduced further. Let me just connect that 4 there. 2t squared plus 5, no GCF, not a trinomial, not a difference of two squares because 2 is not squared, 5 is not squared, not a minus sign. I see a minus sign here, but it's not a difference of two squares because 2 and 5 are not square. T squared is, but 2 and 5 are not, which means I am factored completely. When you see these complicated problems, you always want to think GCF first. One more problem for this video I want to go over, because I want to make sure you remember how to do this, and that is when there's 4 terms. A 4-termed polynomial, the way we factor it is with a process called grouping. It's connected to the AC factor grouping, if you remember that, and there's a good chance you'll see some of that maybe tomorrow in class. We're not going to cover it in the video. I'm going to let you see if you remember how to do it. But when there's 4 terms, you do the grouping part, kind of like, just a real recap for AC, you split the middle into 2 parts, and then you have 4 parts. Well, that's kind of what we have now. We have 4 parts. And so the grouping part is you cut it in half and you group. You group the 2 on the left and you group the 2 on the right. And you factor them with a GCF. So x cubed plus 3x squared, I could take out an x squared, and I'll be left with an x plus 3. Then on this side, I could take out a negative 4, and I'm left with an x plus 3. And remember, when it comes to grouping, it's vital that these match. And not only do they have to, but it also is a good way to confirm you're right so far. Then you combine the GCF from the left and the GCF from the right to be a factor, paired with the common quotient x plus 3. And then, just as always, we want to re-examine, can anything be factored further? X plus 3 certainly cannot. Let me fix that, it's a little sloppy. X plus 3 cannot be factored further. But x squared minus 4 is a very recognizable dot that we're very familiar with. That's x plus 2, x minus 2. And, sometimes you can factor further, sometimes you can't. But in this case, we could. And so our answer is B. So we'll have fun with this tomorrow. See you.